Hello, hello. We are on video 3. This is about exponentials. So you are looking for the paper that looks like this on exponential functions. So that's what we are working with today. I'm going to go over this with you. This is probably the most important topic in my opinion because it's not too hard if I know what the function's supposed to look like. They give you this function right here on the reference page. You just have to know how to use it. And they tend to, on your test, like to ask about it a lot. So first off, with my exponential function, it could be growth or decay. So this might be a plus or a minus. The A stands for your starting amount. The 1 is always there. It stands for 100%. R is your percentage as a decimal, and X right here, sometimes it's T, is your time. So here's how this first one works. I have this expression, and I'm asked what the 2649 is. Well, since it's at the beginning, it's the starting amount, and so answer choice-wise, I know it has to be something about the start. But if I look back at this table, I don't know the starting amount. I know the year that was 3 years after the base. So if I work backwards, I find out the starting year was 1995, and so that was your amount of elephants then. Number 2, I know it's hard to read, but it's basically saying you have 270,000 bacteria. The population is growing at a rate of 2.9% per year. So you have 270,000, 1 plus since it's growing. Remember, to write 2.9%, you move the decimal twice and get 0.029. You also could just go ahead and add those together, and don't forget to put X or T for your exponent. Number 3, you're starting with 25,000 people. It's important if they tell you to use V of T that that's the variable you actually use. We're starting with 25,000. It's decreasing, and I have to turn this 2.5%, move the decimal twice, into 0.025. So you might have this, but you also could just go ahead and subtract it. Don't let it throw you off if this is multiple choice and you don't see this top answer, but you see the bottom one. It just means they subtracted. Number 4 right here, I'm not worried about. Number 5, I know it's sideways. We can flip it. Where'd it go? Number 5 right here. So Jamie deposits $627 into an account. It is compounding quarterly. So guys, if you see this word compounded, you have to think about our compound interest formula. It will be given to you, but again, you have to know what the parts mean. I've labeled them for you here, and now we just plug into it. So I start with $627. Interest is always going to make your money go up. So it's always 1 plus. The percentage is 3.5. I move the decimal twice and get 0.035. Number of times I get the money. So this N value in my formula is new, but I get that from the words. It says I got the money quarterly, which means 4 times. So that's why I plugged in a 4 there, and T is still my time. So this would be my formula. I could plug in any amount of time, 2 years, 4 years, 8 years to find out how much money that would be, but no, this 4T is in exponent land. Number 6, so this is a special case where my number is doubling. So because that's not a percent, I don't do the whole 1 plus thing. If it doubles, you just put a 2 in parentheses. I start with 5, it's doubling. If it was tripling, you'd put a 3. If it was halving, you'd put a half. And that's how that's going to work for you. All right, let's go to this back page. Let me do a few flips here. All right, number 7, what is it increasing by? So these are my favorite questions because there's not a lot required, and if you know what you're looking for, they can be super easy for you. So when they give me an expression and they're asking for the percent of change, I look in the parentheses because that's where the percentages go. So I see 1.02 in parentheses here. First question I'm going to ask myself is, okay, what percent is 1.02? Move the decimal twice, it's 102%. I know this parenthesis always starts with a 1 in it, so that's 100%. So my question should be, what did I do to 100 to get to 102? I added 2%, so this is a 2% increase. In number 8, 0.995. First question, what percent is that? I moved the decimal twice, it's 99.5%. Second question I ask myself is, okay, what did I do to 100 to get there? I subtracted 0.5%, so this is a decrease of 0.5%. Number 9, 1.04. What percent is it? 104%. What did I do to 100 to get there? I added 4%. Number 10, 3 times 2 to the t power. If I want to know how many bacteria there are after 5 days, well, t is time, so I just plug in 5 for t. I type that in my calculator and I get 96. Now, with that same expression, the starting amount would be that first number, which is 3. And because what's in here is greater than 1, I know it increased. But I still ask myself, what did you do to 1 to get the 2 that's in there? 1 plus 1 would get you 2, and the number 1 stands for 100%. So this is actually an increase of 100%. Okay? Lastly, 11 and 12 over here on the side. So number 11, if you have 30 bunnies and that amount is increasing by 8%, so start with 30, 1 plus 8% is 0.08. They increase monthly, but it's been a year. So you would ask yourself how many months in a year. That's where we got the exponent of 12. We plug this in the calculator and we find out there are 75 bunnies. You actually get a decimal after that, but you can't have a decimal part of a bunny. Lastly, number 12, the size of the bacteria reduces by half. How large will it be in a day if it started at 2 millimeters? So I start with 2. 1, it's decreasing, it's reducing, so I do 1 minus. A half is like 50% or 0.5, so that's my decimal here. Now the tricky part is this time up here. Here's what you have to think about. It cuts in half every 3 hours, and it's been a day. Well, a day is 24 hours. How many times does 3-hour cycles come up in 24 hours? It would come up 8 times. So this is going to cut in half 8 times, and you would end with 0.0078. So if you have questions about that, come see me. But this is the page to make sure you really know you get, because it tends to be one they like to ask about a lot. But I know you're going to do great. I'm so happy that you were here and took time to watch this, and have a fantabulous day.